In response to the large number of global challenges our society is facing, the European Commission implemented several dedicated actions and established a number of scientific projects to meet these challenges. One of these projects is the Centre of Excellence HiDALGO, whose consortium consists of 13 academic and industrial institutions from 7 European countries.
So basically HiDALGO is a European project. It's funded by the European Union, and it's a project in high-performance computing. So the main goal is to design and to develop methods, algorithms and software for high-performance computation for large supercomputers.
So high-performance computing allows us to produce a lot of data, and data is currently the gold which we have in our hands, and really something which is of highest value. So by starting to understand this data, and data is manifold, we are able now to understand better the different facets of the parts we are looking at. So HPC is the tool which can help us to support really understanding complexity behind societal challenges.
Within the project we have several use cases. So basically pilot applications on which we focus, and these pilot applications are basically on one hand side the migration, so refugee migration, then pollution, air pollution in urban areas, then the social networks use case for which I'm responsible, and the COVID-19 simulations. This came after the beginning of the project, but this is basically a main global challenge. So we thought it's very important also to develop solutions for this kind of applications.
London, UK, one of the most important economic, transportation and cultural centres in Europe. It is the home of several universities of the highest international reputation. The research group directed by Derek Groen at the Brunel University leads 2 of the major pilot applications within the HiDALGO project. One of these main use cases deals with probably the biggest global challenge our society has faced during the last 2 years, the COVID-19 worldwide pandemic.
In the case of the COVID-19 use case, the flu and coronavirus simulator, our motivation was very direct. We were approached by the NHS that they had a need for a simulation code that was able to predict the spread of COVID-19 in a local area. So not so much a national code that would predict the trends across the whole of the UK, but a code that would predict the trends locally within the catchment area of their hospitals. What was quite tricky in this particular use case was that we had to develop the code from scratch when we were asked during the first pandemic wave. So we had to familiarize ourselves with the properties of the disease. We didn't know much about COVID at the time, about how it would spread, whether it was more airborne or more through surface transmission. We had to understand how we should code up the behaviors of people visiting different locations. And also the development itself was tricky because we were developing it during the lockdown. So in my case, I was doing a lot of the coding with the children in the background, basically.
Migration use case, it was developed in 2016 when there's a high number of migrants fleeing from African countries to European Mediterranean Sea. Another motivation behind our research for migration use case was that when there are border closures between countries, how does actually affect the number of refugees fleeing from conflict situations? Or camp displacements, how that actually influences the movements of people. And we try to understand how many people actually arrive to European countries. In relation to scientific challenges we faced is that there was nothing done in relation to forced migration. So we had to do everything from scratch. There is no available data in relation to forced migration publicly available. If there was data available, but it was incomplete. So we had to face with not only not knowing actual data in relation to forced migration, but actually kind of develop everything from ourselves.
The High Performance Computing Center in Stuttgart is the home of one of the 6 most powerful academic supercomputers across Europe. Furthermore, it is one of the 3 Gauss centers in Germany. The scientists working at the center are internationally renowned for their expertise in hard and software of HPC. For the applications of HiDALGO, it is crucial to have access to the supercomputer, as well as to the expertise of the researchers at the High Performance Computing Center in Stuttgart.
Also, if you look at the pandemic, we need to inform politicians about some decision making. So we cannot wait weeks and months until we get some results. So here we can leverage the power of high performance computing to get these results in a timely manner with high accuracy.
So HPC is very important because it gives us the tool to really map complex problems to a virtual world, to a simulation and a model, and by that to start also playing around with this and to understand what is really happening here.
Győr, the beautiful and vital city on the Danube River, hosts one of the leading universities in Hungary. The Department of Applied Mathematics, led by Zoltán Horváth, develops the main solutions within the HiDALGO project for reducing the air pollution in cities and urban areas.
We would like to provide enough traffic and as low air pollution as possible. And for that we need these computations. One could ask why not to measure the air pollution? It's also possible, but certified measurements of the air pollution needs very expensive and very big equipment. And it's impossible to require that the air pollution in a city may be measured at very high accuracy. It's impossible. In each city, by European regulations, there are certain certified measurement points. But for example, in Győr, there are only 2. And with these 2, we cannot expect representative measurements which is valid for the whole city. There is a huge variability of the pollution in a city. Because of the wind flows from one direction, it mixes the polluted material coming out from cars and also from the neighborhood, from the houses, from the buildings. When for the heating we produce a lot of pollution as well. Now in this project we are concentrating on the traffic emitted pollution, and according to the position of the buildings, it makes the flow interesting and unpredictable flow motion. So if we would like to compute it, because we cannot measure it, but it's needed to be measured because there is a big variability of the pollution in a city. Therefore, we have to compute it at high resolution. And this is the point why we need high performance computing, HPC.
Salzburg, Austria, one of the most touristic places in the Austrian Alps, hosts a university with a long-standing tradition and excellent research performance. The Efficient Algorithms Group, led by Robert Elsasser, develops novel methods, algorithms and simulations for the spread of messages in social networks, which is one major pilot application in HiDALGO.
And as I said, so my main responsibility within the project is to lead the social networks pilot applications. So we know that social networks or social media is very important in our everyday life. So many people basically interact with other people using social media. You know, Facebook, you know, Instagram, you know, Twitter. So you post messages, you interact with others, you basically share information using these platforms. There are also several groups which use this social media to spread news, to spread messages. Some people are using this in an honest way. There are also other groups which use this social media in some dishonest way. So they try to spread false messages, they try to influence the behavior of people using malicious information. So for this, we must understand the dynamics behind the spread of messages in social media to be able to differentiate, is this an honest way to spread, to disseminate messages, or is this a dishonest, false way to spread messages? So on one hand side, we want to understand the dynamics behind the spread of messages. On the other hand, we want to be able to differentiate between different behaviors on social media.
The historic city of Poznan is a centre of education and technology, and it is the home of one of the most powerful and modern supercomputers in Poland. The scientists at the Poznan Supercomputing and Networking Centre have an excellent international reputation for their expertise in parallel programming, the heart of high-performance computing. Working on the interface between hard and software, the experts of the centre optimize the programs developed in the use cases of HiDALGO.
PSNC is a supercomputing center, so as such we are responsible for providing an access to computational and storage resources. Moreover, PSNC uses its expertise for facilitating implementation of data analytic solutions and code optimization with GPU accelerators involved.
Our simulations generate a lot of output data, which we have to manage and examine. And to do that effectively, we are employing advanced data analytic frameworks like Spark and machine learning on graphical accelerators.
From the formal point of view, the role of HiDALGO encompasses project quality management, leading the biggest work package, oriented on scalability, optimization, data analytics, data management, and visualization.
The best thing about this project is that we can deal with the most advanced and most recent technology in a way that has not been done before.
This is also a point why I chose this topic for research. I could have chosen between many topics, but I like that to make scientific results to help making cleaner air in cities.
These global challenges must be somehow modeled and must be simulated in order to make forecasts, to make predictions.
Global system sciences are related to the situations which are applicable to many places in the world. It means that many of us are facing the same problems across the world, and they can be solved by very similar approach using the HPC, HPDA, and visualization methods.
We have a lot of new fields where we are working on, where we want to have an impact on the future, and I don't see yet that we have reached this level where we should stop simply. So the idea is simply to continue on doing this and seeing how much positive impact we will have on the future and how we can really show what is possible if you do the right investments.
Of course, supercomputers are becoming bigger and bigger, and it will be more and more challenging to use these huge resources in a cooperative way, to let them work together to solve big problems.
We have these very expensive tools here. We have a lot of excellent people.
Because it's not really possible to do it on your own. The supercomputers, they are huge and they are expensive, and they allow you to do stuff that is simply not possible to do on your own. And here we can deal with it all.
So we have so many experts from different domains that exchanging ideas.
I want to find out what is the maximum we can achieve with that. And the most important part is I want to work on real problems.
Bringing something forward is really fulfilling for me.
Once it makes a click and you say, that's why it happens, how it happens, this is a huge satisfaction, at least for me, and I think also for others, to gain this understanding at that point in time.
The vision of HiDALGO is, we advance technology to master global challenges. Since its start in December 2018, the scientists of the Center of Excellence HiDALGO developed several software products to model and predict the evolution of the COVID-19 pandemic, migration flows towards Europe, the pollutants emitted by traffic, and the spread of messages in social networks. The scientific value and societal impact of the achievements of HiDALGO have been demonstrated in a number of interdisciplinary publications and by their use in real-world applications. Access to extremely powerful supercomputers and the know-how of leading experts in high-performance computing was of key importance for the success of the project. The Center of Excellence HiDALGO is a prime example of a successful European project intended to provide solutions for global societal challenges of different types and nature.